This is Dr. Holt. I want to go over how to set up a problem where I have a pulley, has no mass, and I have 3 masses hanging from it, and we want to find out what the acceleration is. I'll write that down here. I want to find acceleration. We want to find what the tension is here. We'll call that T1. We'll call this T2. And we'll have T3 here. Okay, it's important here that we have no mass. If we do have mass, then the tensions here will not be the same. Alright, to set up a problem like this, draw yourself a free body diagram or a force diagram, whatever you want to call it. It doesn't really matter where you start. I will start right here. And when I draw that, I will have 3 times 9.8 coming down. So I'll have the force of gravity, I'll call it F of G, force of gravity of the Earth onto the 3. And that would be equal to 29.4 coming down newtons. I'll go ahead and show a vector coming back up. We'll label that as T3. Now what I recommend here is decide what direction you want your acceleration to go. Excuse me, it really doesn't matter if you get it wrong or even if you do the wrong direction. It all works out. We'll look at this. We have more mass here, so we assume it's going to accelerate this way. So we'll say anything that goes down here to be negative. So I'll come down here. I'll draw my vector off to the side here. And again, I'll make this as my mass times acceleration. I'll just make it red. I'll go ahead and do that in black too. So this is mass times acceleration in y coming down. We'll make this tension vector also going up. Alright, so this is the first force diagram or free body diagram. Again, this is for the 3 kilogram mass. We can come up with an equation immediately for it. We're going to let anything that goes down be negative, anything that goes up be positive. So we can say that T3, excuse me, the vector T3 minus 29.4 newtons is equal to mass, which we know in this case is going to be R3. Times acceleration in the y direction, like that, and we put that in -2 because this is going down and this is going down. So that's our first equation. Alright, we'll jump back up. We'll do the force diagram of this one right here. I will have T3 vector coming down. I will have what I call it T1 going back up. I'll shorten this a little bit because we know it's accelerating down, so this vector should be a little bit shorter than the other one. And we will also have the mass times gravity coming down here. Label that a little bit better. I can draw a straight line here. Okay, so this would be the force of gravity, and again that's going to be the Earth on the 5 kilogram object, and that would be 5 times 9.8, so that'd be 49 newtons in that direction. And then off to the side we'll put mass times acceleration, and this time I'll just go ahead and put 5a. Go ahead and color it red also so we don't think it's a force. Go ahead and put our little vector signs there. Okay, so again, we can come up with an equation from that one. Number 2 equation. Again, anything goes down be negative, anything goes up positive. We will have T1 minus T3 minus 49 is equal to minus 5. Select that as vectors 2. Okay, then we have question number 3. Draw a force diagram of the other 5 kilogram. Again, this force diagram, or free body diagram, is of this 5 kilogram mass here. We'll go to this one. Now it's going to be accelerating upward. So off to the side here, we'll draw that. We'll color that red to note that that is just mass times acceleration. And then we'll go ahead and label everything. So this would be T2. This would be the force of gravity, again, of Earth onto the 5. And that would be 49 newtons. And this would be 5. And this would be AY. From that equation here, we will get T2. Now T2 is going up. Minus 49 is equal to 5 AY. Okay, so there's our 3 equations. Okay, so let's talk about how many unknowns we have. Now, one thing we do note, since we have no mass in this system, we can say right now that T1 must equal to T2. Okay, so what I'm going to do to solve this problem is on equation number 3, I'm going to substitute in here, and I can say that T2 is going to equal to 5 times AY plus 49. That's from this equation. I'm going to substitute back in to the second equation. Now we know that T1 is equal to T2. So using the second equation, I can say that 5 times the acceleration of y plus 49 minus T3 minus 49 must equal to minus 5 times acceleration times y. What I'm going to do here is I'm going to solve for T3. Now you note here that my 49s are going to cancel out here, and oops, yes, it is right, that is 49. Cancel out there and there. So I can just go ahead and solve, and then I'll move T3 to the other side, move the 5AY over. That's going to give me that 10AY is equal to T3. We'll take that equation right there. We're going to put that back into the first one right back up here. That's going to give me 10. Come back, I make a mistake. It gives me 10 AY minus 29.4 is equal to minus 3 AY. Now, your sign convention is critical here. You have to be very careful that you get the signs going right and not make a mistake there. Move this to the other side. We'll get minus 29.4 is equal to minus 13 AY. Solve for AY. We take 29.4. We divide it by 13. It gives me acceleration of equal to 2.26 meters per second squared. Alright, now we have the acceleration of AY. Again, we'll go ahead and just show that as a vector. Now we can substitute back in and find our other unknowns. We'll come back to T2 right now, put it back in here. So we know that T2 is equal to 5 times 2.26 plus 49. We'll do that real quick. That gives me a tension of about 60.31. So we have that one. And now we know that T1, well, we say T1 is equal to T2. So we also know that T1 is equal to 60.31 newtons. Now we come back to do T3. And let's work our way back up and see what we can solve for T3. We can actually go right here and solve for T3. So we know that T3 is equal to 10 times the acceleration of 2.26. So 2.26 times 10 gives us 22.6 newtons. So T3 is equal to 22.6 newtons. And now we found the tensions in all three cables, and we also know the acceleration. So this is a good example how to solve. The most important thing here is that you draw your free body diagrams or your force diagrams correctly. Make sure that you label, have some type of system where you have anything goes down in this example to be negative and it goes up to be positive. It doesn't matter what direction you go with as far as what's negative and positive, as long as you're consistent in that system. I did that for 3 different systems. I did it for the 5, the 3, and the 5. And from that I went ahead and set up my 3 equations and I solved. And these are the steps you're going to use to solve these problems. Alright, best of luck.